Ian Kerr is with me this afternoon, over 100 patents and quite a lot of trade secrets in his working life. Ian, one of the things that worries me about academia is that the old joke about professors knowing more and more about less and less is horribly true of many professors. I think it's not true of you, but it is true of many. Is one of the problems we have, do you think, that we don't have enough people now who can think across disciplines, and we're rather bad at getting people with different disciplinary backgrounds to work together?
Yes, what you need is, think of it as like a catalyst in chemistry. So you need those professors who are really deep in their subject. But you need to have somebody who can understand the language that they're talking and go and talk to a completely different discipline and join them up. And that can be maybe mixing between chemistry, medicine, engineering, material science. You see this at some universities. So a university that I've done quite a bit of work with in the past, Queen Mary University in London, deliberately moved the medicine, the law, and the engineering and the material science all into the same building,
Right.
and all into the same school to try and get them to work together.
Did that work? Did they work together, Ian?
They did indeed. And an awful lot of quite interesting ideas came out of it. And they rose from something like 500th in the rankings to now being in the top 100, maybe even the top 50, I think, this year. But what I used to enjoy when I went down to look at some of the student projects was just how much crossover there was between materials, engineering, and medicine.
Yeah.
And that they were coming up with things that people would not otherwise have thought of. The bit that was missing was that they never joined in electronics or mathematics. So, but your space is limited in a university as to how you get those people together. But I just give that as an example.
Yeah.
We did the same thing at Southampton, getting the marine people in with the engineering and the medicine just round the corner. And what it meant was that we shared things like TEM microscopes, tunneling electron microscopes. But it also meant that when you got an unusual result, you would get somebody from the other school having a look at it and providing some of their insights into that.
Yeah.
And sometimes it was just very simple things, like they would say, "Oh yeah, I've seen that before. That's because you haven't applied the gold layer properly." And that is the real help. And that's how that things should accelerate quickly.
So one of the challenges, obviously, with flight, I remember sitting in Manchester listening to a pilot talking about all the ways in which you could improve the efficiency of an aircraft and reduce fuel emissions just on known technology by just pushing up the efficiency, pushing down the amount of fuel you were burning. Do you think we've made all the progress we can make on that, or are there more gains that could be made?
No, there's a huge number of gains still to be made. And that's partly because we're not working together. So your first thing is that your propulsion plant is a significant part of the drag of the aircraft.
Right.
If, a bit like a fighter aircraft, the engine is integral and built in as part of the aircraft, so you're sharing structures, there's a benefit there. There's looking at the aerodynamics of it. So if you think of Concorde, they tried to sort out quite a lot of the drag off the wings, and a lot of that still hasn't been applied to modern aircraft.
Right.
So if you look at a modern aircraft, a lot of the vortex spills are where the wings join the fuselage.
Yeah.
So something very simple would be for your hotel mode is to take an air offtake right at that point and suck the vortex down.
Why don't they do that? I mean, even to me as a non-engineer, that sounds like a sensible thing to do.
The old TriStar did it.
Right.
Where the tail joins the fuselage, they put an engine and sucked it off. And so you get that extra benefit when that's running.
So why stop doing that?
It's really because people have forgotten it, and people, it's as you were saying before, your professor has gone into his silo and he is designing his super efficient gas turbine and not thinking of it as a system.
Yeah.
So I would encourage everybody to go and sign up for a course at Encose and do some systems engineering to really understand it from start to finish before they try and solve a problem. When you introduced me as a structured thinker,
yeah,
I have a range of tools that I use, and systems engineering is the number one on the list because you start with that requirements capture. Even if your manager has told you, go and do lean engineer that product over there, well, actually, what you might do is to do the systems thinking first and discover that actually the whole of that process can disappear.
Right.
So there's no point leaning it if you can get rid of it.
Right.
But you can only get rid of it if you're thinking of it, how it sits with everything around it. I did that at Rolls-Royce, that the manager of one of the machine shops, they had wanted to buy, well, they just bought a brand new machining center. And this was for machining the linings for the compressor. And so I sat down and thought about this, and what he wanted me to do was to sort out the problem that there's an awful lot of fine dust coming off, and his brand new £2 million machine kept getting gummed up and stopping.
Right.
So I did the systems engineering and went back and had a look at the process of applying the filler, and discovered that I could change that process and apply the filler to within about 2 thou, which was within his final machining tolerance anyway.
Right. Taking out a whole stage in the production process.
Well, he was furious because I just removed the complete need for his department.
Right. I can see that would be upsetting.
Yeah, he never invited me back.
No.
But that's why you need to start with how does this fit in the system, but also then taking in some of your TRIZ tools that says, well, okay, now I've got my requirements. What's my ideal result? What am I aiming for? And unless you know what you're aiming for, you can't do your QFD or your house of quality, whatever you want to call it, because you don't know how am I going to score my possible solutions if I don't know what I'm aiming for and what's ideal.
So systems engineering is still taught in the UK. How many engineers would have done it?
Virtually none.
And how does an obviously useful discipline like that disappear?
Because so many people find it difficult. One of my, the trainees that used to come into my department, I used to send them on the systems engineering course because I'm a great fan of it. And one of them came back and he said, I did quite well. And I said, what do you mean? He said, well, Richard told me that this is a second best score that he's seen. And I said, oh, yes. And he said, there's only one person that's beaten you. And Richard named me.
Does that course still run, or has it stopped?
It's still run, yeah. So Richard Beasley is a very, he also writes academic papers. You can look him up. He's very keen on systems engineering. I think.
But he's virtually a lone voice from what you're saying. It's not.
Oh yes, yeah. He was finding not a lot of people in Derby were listening to him, and he moved down to Bristol. Bristol realised the importance of what he was doing, gave him a job down there.
Right.
But this is what Lucy was saying earlier. This is why the company is struggling, is because it's not recognising. Because the manager would say is, well, just get on with the job. You know, why you sit down going back to principles? We know what we're doing. Just get on with that lean engineering I asked you to do.
Yeah.
And I'm saying, well, yeah. If I just do the lean engineering, I might get 10% out. If I do the systems thinking, I might get 50% out.
So if I asked you what you would guess might be got out of aviation pollution, greenhouse gas emissions, how much do you think might be got out just by systems engineering?
I think there's a fairly easy 20 to 25% up for grabs.
On top of what we've already got?
Oh, yes.
Very interesting.
The guys at Boeing sort of understand it, but the seniors won't let them do it.
Right.
The guys at Toulouse don't really understand, but they can see there's something in it. The guys at Bombardier say, no, we're just making tubes with wings and we're just getting on with it. And they're not worried because they're tending to make business jets, and as long as they're making a profit off some high-priced item, they're fine.
Yeah.
For instance, I did work out how to make, well, you know, fool's gold.
Yeah.
I worked out how to make a titanium version of fool's gold. So what I was trying to say is, for our small business jets, we can reduce the life of the fan blade considerably, but have it gold.
Right. At
a premium for particularly our Arab customers who like the bling.
The idea. Yeah.
But the company wasn't prepared to do it. And I said, look, we will, if we make gold, what appears to be gold-plated fan blades, we will knock the opposition off the pitch.
Yeah, absolutely.
In that market. Because if you look in Arabia,
yeah.
Friday afternoon, they're all there at the airport, sitting outside with their personal jet out there, a bit like people in Britain used to be 50 years ago on a Sunday afternoon washing the cars on the drive.
Yeah, absolutely.
It is the same mentality. And you're saying, well, okay, if you want them to buy our product, you've got to give them that little extra.
Yeah.
But you don't give it for free. You tell them it costs more.
Yeah.
And the reason you do that is because the next door guy who hasn't got it knows it costs a lot more and he can't afford it.
Yeah, absolutely. It works all the time.
Yeah.
Extraordinary.
And it doesn't matter at all that you have reduced the life on it, which you would have to do because the surface treatment doesn't give you as long a life as a pure titanium oxide does.
Ian, thank you very much. That's been fascinating.